Hi and good evening, everyone. Thanks for hanging around. So we'll just start off. So in today's session, we'll be solving problems on some basics of digital electronics. All right. So yeah, we'll just start off now. Let me share my screen and we can start off. Okay. So we will start off with the first question. So can you just confirm if you are able to see my screen and my voice is audible?
Yes, sir. The screen is visual and the voice is clear.
Hello,
Okay.
sir.
So we will
Hello,
start.
sir.
Hello.
Yes, sir. Your voice is audible, sir.
Okay. Thank you. And my screen is visible, right?
Yes,
Yes,
sir.
sir. It is visible properly.
Great, great. So we'll just start off. Okay. So as I told, we will be solving problems mostly on digital electronics. So let me start off now with the first question. Um, so the first question is to convert from binary to decimal to hexadecimal and octal. Okay. So let's open it. Yeah. The binary octal and hexadecimal equivalent of the decimal number 220 220.220, right? Based in R dash dash and dash. Okay. So basically you need to convert this number to binary, octal and hexadecimal, all right? Okay. Okay. So this is actually a very simple question, right? So what will you do to convert anything to binary first? So decimal to binary, how do you do it? So you have 220.220, right? Okay. So how will you convert it to binary? So one thing is for to convert a decimal to binary or decimal to any base, right? So you will divide by that number and see what is the remainder. So let's take just the part before the decimal, right? Just the 220 alone. Okay. So 220, you divide it by 2. What you end up is with 110, and there is no remainder at all as such, right? Because 2 is directly divisible by 220. 2 divided by 110, no remainder at all, you get 55, right? Now you divide by 2, you see that there is going to be a remainder 1, right? Because 2 into 27 is going to be 54, and there is a remainder, right? And 2 divided by 27, there is a remainder of 1 because 2 into 13 is 26, right? And again, you divide 13 by 2, you get 6 with a remainder 1, right? And you divide 6 by 2, you get 3 with a remainder 0. And you divide 3 by 2, right? How much do you end up? You get 1 with a remainder 1. Okay. And again, you divide this by 2, right? 1 by 2 is again going to be 0 with remainder 1. So this is your end, right? This is your end. Okay. So now you have to read it from bottom to top, correct? You have to read it from bottom to top. So yeah, we have been dealing with this particular part, and you have to read it from bottom to top, something like this, which means that the number is going to be what? The number is going to be 1101 11100. Okay. Yeah, sorry. So I think here we made a mistake. So perfectly divisible. So 1100, and then yeah. Sorry. Yeah. So, and yeah, this will be 0. Correct? Yeah. So this is your number. Okay. In binary form. So this is about your number before the decimal. But what about the number after the decimal, right? So what about this particular part? So for a number which is after the decimal, you do the complementary, that is you multiply. All right. That is basically what you do is, so you have your fractional part. Your fractional part is 0.220, right? So 0.220, and you do into 2, right? You get 0.44, right? So you look at the units place. You look at the units place now, right? It is 0. Okay. Which means that the corresponding number is going to be 0. Okay. Corresponding number would be 0. Now what you do is 0.44 into 2 is equal to 0.88. Again, you see that this number is 0, right? So you get a 0 over here. Now what you do is 0.88 into 2, it's going to be 1.56. Therefore, what you have in the units place is a 1, which means that there is going to be a 1. Okay. And now what you do is, yeah, so 0.88 into 2 is 1.76, beg your pardon. Yeah, 1.76. Okay. So there is going to be a 1 over here, right? Okay. So again, what we do, 0.76 into 2, which is going to be how much? 0.76 is into 2. It's going to be yeah, so it's going to be 1.52, right? 1.52, which means 1. Okay. And again, 0.52 into 2, it's going to be 1.04, which means again it's a 1. And then what happens? 0.04 into 2, it's going to be 0.08, which means it's a 0, and so on. So what you see over here, you have to take it from, you have to read it this way. All right. That is 0, 0, 1, 1, 1, 1, and then so on. Right. So the number after the decimal, right? The number after the decimal is going to be 0.0011110. Okay. Therefore, the total number is what? 1101100.0011110. Okay. This is what is 220.22. Is this fine? So the number before the decimal, you have to divide it by 2. Okay. And the number, and see the remainder. And the number after the decimal, you multiply by 2 and see the units place. Okay. Okay. So okay, so the next part is, so we have found out the binary. Let's find out the octal part. All right. So how do you find out the octal part? Again, the very same procedure that we follow. That is, you divide by 8. That is one way. That is, you can divide by 8 and multiply by 8. That is one way. Or the simpler way is, once you have the binary, right? So you have the binary over here, which is so the binary is 1 1 1 0 1 1 1 0 0 0.00111 Okay. This is your binary form. For what? For 220.22. Okay. Now what we can do is to convert it into octal, right? So convert binary to octal. Okay. To convert binary to octal, you group in terms of 3. Group in sets of 3, which means that you kind of end up with 100 as one group and 011 as the next group, and you have a 11 over here, right? Similarly, over here, 011 is one group and 10 and then something as the next group, which means that you will pad it additionally with an extra 0. So 011, then 011, then 100. Okay. 0.011 100. Okay. This is how you have padded it, and now you can easily guess, right? Now you can easily tell that this can be easily written, right? That is your 011 is going to be 3. 011 is again 3. 100 is 4. and 011 is 3, and 100 is 4. So you end up with 334.34. Okay. Yeah, okay. So it is I made a mistake while writing here, so it is actually 001. Okay. So 001110. So 001110. So again, let's rewrite the order over here. So we end up with 001, then 110. Okay. So 001 is 1, and you end up with 4. Yeah. So this is your number in octal. Okay. So that is 334.14. Okay. This is what you get in octal. Okay. And finally, for hexadecimal, right? For hexadecimal, you group in terms of 4. Group in sets of 4, which means that which means that 0, 0, 1, 1 is one set, and 1, 1, 0, 1 is the other set. Right? Likewise, over here, 0, 0, 1, 1 is one set, and 1, 0, then you pad extra 2 zeros. Okay. So, yeah. So this is how you have padded it, right? So you know very well that 0, 0, 1, 1 is going to be 3. Okay. And 1, 000 is going to be 8. Okay. And what is 1100? What is 1100? So 1100 is going to be 0 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 power 2 plus 1 into 2 power 3, right? Which is 8 plus 4, which is 12, right? So what is 12? 12 is going to be C, right? Represented by the letter C in hexadecimal. Okay. So this is C, and 1101 would be D. Okay. So your number in hexadecimal is going to be what? It's going to be DC 0.38. Okay, so you have found out the numbers in binary, octal, and hexadecimal. Okay. So to find out in octal and hexadecimal, it's better you do it in binary and then group it in sets of 3 or group it in sets of 4. Okay. That will give you the answer, and always the reference point should be your decimal. Okay. Your reference point is your decimal point. Okay. Okay. So I hope the first question is clear. Next, let's go ahead with the next question. Okay. So the next question is also on number systems, that is convert 11101 01 011.101 to decimal, octal, and hexadecimal. Okay. So how do we solve it? So 111.101, right? So this first we have to convert it into decimal. Okay. To convert to decimal, what do? We just look at the units place and directly multiply in powers of 2. This is units place, right? That is, you have 0, 1, 2, 3, 4, 5, 6, 7, right? So the answer would be 1 into 2 power 7 plus 1 into 2 power 6 plus 1 into 2 power 5 plus 0 into 2 power 4 plus 1 into 2 power 3 plus 0 into 2 power 2 plus 1 into 2 power 1 plus 1 into 2 power 0, right? And this would be minus 1, minus 2, minus 3, right? Therefore, 1 into 2 power 0 plus 1 into 2 power minus 1 plus 0 into 2 power minus 2 dot 1 into 2 power minus 1 plus 0 into 2 power minus 2 plus 1 into 2 power minus 3. Okay. So let's solve this. How much are we getting? So we have 2 power 7 plus 2 power 6 plus 2 power 5 plus 2 power 3 plus 2 plus 1. So you get 235.1 into 2 power minus 1, right? That is 1 by 2 plus 0 into 2 power minus 2 plus 1 into 2 power minus 3, that's 1 by 8. So you get 0.625. So this is in decimal, okay, 235.625. Okay, just we have multiplied with the place value. Okay, we have just multiplied with the place value. Then what do? You have to convert it into octal. Okay, so let's write down the same number once again. So you have 111 11011011 0.101. You have to convert it into octal, which means you will again group in terms of 3, right? So let's rewrite this in terms of 3. 110 is one group. You have to write from the decimal point. Okay. 0, 1, 1, then 1, 0, 1, and 0, 1, 1. Extra, we have added a 0. Okay. So this can be written as 0, 1, 1 is 3, 1, 0, 1 is 5, and 0, 1, 1 is 3.101 is again 5. So 353.5. 353.5 is the octal number. Okay. So this is for grouping in sets of 3. All right. And next is we group in sets of 4. Or hexadecimal. Okay. So let's group in sets of 4. So 1, 0, 1, 1. Right. 1, 0, 1. Let's add another 0. And you have 1, 1, 1, 0. Okay. So this can be written as this is your number E, right? Because this is your number 14. Okay, this is 14, which is E, and 1011, right? This would be your number 11, which means this is going to be B, right? And 1010 is going to be your number 10, right? So this is your number A. So in hexadecimal, your number is EB.A. Okay. So remember that in hexadecimal, your numbers are 111 is 7. Till this, I think you know. So 0, 0, 0, 1, then 0, 0. Zero, 1, 0, 0. Then 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, then 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, then 1, 1, 1, 1. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you know that from 10, it is called A, B, C, D, E, and F. So that is how we have sorted it out. 1110 is E, number 14. 1011 is B. Okay, fine. Okay, so this is about number systems. That is how you convert. Okay, so let's move on to the third question. So the third question is,
Sir, can I ask one question, sir?
sure.
Actually, sir, I was going through the assignment questions. There was
Okay.
the first question was the output of 2 input OR gate is high, and I don't think any of the options is actually matching OR gate, sir. So I'm a little bit confused on that, sir.
Sorry, what is the question?
The output of 2 input OR gate is high,
Hmm.
So the answer should be actually when at least one of the inputs is high, the answer should be high, sir. But in the options, that is not there, sir.
Listen, one thing is that regarding the assignment questions, like we have been strictly asked not to discuss current assignment questions. So
Yes, sir.
it isn't a good idea for me to discuss over here. Okay,
No,
so
actually, okay, but
I
the
understand probably the options are not matching, but if
yes,
there is no correct answer that's provided in the options, generally what they do is after the
yes,
assignments end, they will give free marking to all people
okay.
if who have attended it, I think. So you need not worry if you're convinced about the answer to that question. Okay.
Because for OR gate, sir, if both
Mhm.
the inputs are high, then it will give output, sir. But only if
Hmm.
both the inputs are high, it is AND gate, not OR gate.
Hmm. Correct.
Yes. And
Hello,
if
good
both the
evening, sir.
inputs are
So, yes, sir,
yes,
I
Hello.
have
and
also have the same doubt actually.
Hmm. Got it. Got
Actually,
it. So
I think that options were like some like they have missed one that right option, I think. Actually, sir, what
yeah.
happened? Just you told like that for that grace mark and all. Last time
Mhm.
also we
Hmm.
found one like similar kind of question where the options were like the answer was something different, but
Hmm.
while we checked during that like scores, like we have
Hmm.
got a negative mark. Like I have got the negative mark. That question
Oh,
was
okay.
about the diode. Okay, sir. So a diode is a unidirectional, and the same
Hmm.
time a diode is a nonlinear. Okay. So and
Hmm.
the both option was also there. So I gave both, but it was like I think the option was fade that only unidirectional. That's why I got a 0 mark for that. So similarly, this time also this question came actually.
Okay. Hmm.
yes, also I also got negative mark for that, sir, because I also went for the both A and C option, but it got negative mark, sir.
Yes, yes.
Okay. Hmm. See, actually, I am
What
not
should we do,
responsible
sir?
for. No, no.
Hmm.
Actually, I am not the one who is. I mean, who is setting the questions and correcting it. So it is
Okay,
directly
sir.
related to the
Just
professor.
for
So.
information. So,
Hmm.
if you get some time, you can check whether the questions are actually like what correct or some mistakes is there in that question assignment
Yeah, sir.
question or not.
Okay. Okay. Okay.
Okay, okay, thank you,
Okay.
sir.
Hmm.
Thank you, sir. Thank you.
Hmm. Fine. Hmm. So let's go ahead now. The question is convert from octal to decimal, binary, and hexadecimal. Hmm. Okay. So how do you convert from octal to decimal? So if you have anything and you want to convert it into base 10, right? So you will take the units value and multiply with the corresponding base values, right? So 526.438 has to be converted into decimals number, which means that you have 5 into uh, 5 into 8 power 2 plus 2 into 8 power 1 plus 6 into 8 power 0. 0.4 into 8 power minus 1 plus 3 into 8 power minus 2. Okay, just we multiply with the units values, right? So what you end up is 8 square into 5 plus 16 plus 6. So this is 342 point. So you end up with 342.546875. Okay. This is what you end up in decimal. And if you have to convert it into binary, right? Now it is very easy to convert to binary. Okay. So pi 26.43. So this can be written individually. So 5 is basically what? 5 is basically 101. 0 is 0, 1 0. 6 is basically 1 1 0. And 4 is 1 0 0. And 3 is 0 1 1. So there you go. This is directly written. Okay. That is your 5 is 101, 2 is 010, 6 is 110. In groups of 3, right? As we know. Okay. And finally, we have to convert to hexadecimal, right? So to convert from octal to hexadecimal, better to use the binary number. Okay. So let's use the binary number for now. That is 101. You have 101, then 010, 110.100.10001. Right? So this is in binary. So you want to convert it into hexadecimal. Okay. So what you will do is you will group in terms of 4, which means that these 4 will be together and these 4 will be together, and you have to pad this number. Okay. And similarly, you will be having these 4 together, and after this you will pad it. Right. So after padding, you will be getting something like 0 0 0 1, then 0 0 1 0 1. And okay. So this is the very same thing with padding, and now 0001 is 1, then 0101 is going to be 5, then 0110 is going to be 6.1000 is going to be 8, and 1100 is will be your C, right? This is 16. I think 1100 is C. Yeah. So 100 is C. So this is how you convert from octal to hexadecimal. Better to take the binary route. Okay. Convert to binary, groups in terms of 3, and sorry, you group in terms of 4, and you will finally get hexadecimal. Okay. Okay. So Okay, so the next question is this is the last question on number systems. That's it. So the question is convert phi b e c phi b e 2 point c to decimal binary and octal. Okay. So they have given you the hexadecimal number. All right. So phi b e 2 point c, right? So we know that to convert from any base to decimal base to base 10, we have to convert with the units place or we have to multiply with the units place. Okay. Which means that there's going to be something like this is your units place, ones place, okay, and this is minus 1. So which means you're going to end up with something like 5 into 16 power 3 plus b into 16 plus b into 16 power 2 plus e into 16 power 1 plus 2 into 16 power 0, right? Point c into 16 power minus 1. Okay. So what is b? A is 10, therefore b is 11. What is e? F is 15, e is 14. And what is c? C is 12. Okay. So just substitute it. We'll be getting the answer. So 5 into 16 power 3, 5 into 16 power 3 plus b is 11, 11 into 16 square plus 14 into 16 plus 2. So you get 23522. Okay, so 235.75. Okay, so just we have multiplied with the base value. Now we have to convert to binary. Okay, that is hexadecimal to binary. And so what was the question? The question was phi b e 2 point c in binary, which is basically we have to write in groups of 4. So 5 is basically 0, 1, 0, 1. Then b is actually 11, right? That is 11 would be 1, 0, 1, 1. And e is what? E is actually 14, right? Which is 1, 1, 1, 0. And 2 is 0, 0, 1, 0. Okay. And what is C? C is actually 12, right? So that would be 1100. Okay, just we have grouped in written in groups of 4, you get the answer. Okay, so you have converted from hexadecimal to binary directly. Now that you have the binary number, you group in terms of 3, you get the octal. Okay. So this was the next part. And in next part, we have to convert it into octal. So 16 to it has to be converted to octal. Better use binary. Better use binary for that. Binary and group in sets of 3. Okay. So if we group in sets of 3, what you get is 0, 1, 0, then 0, 0, 1, then 1, 1, 1, then 1, 0, 1, then 1, 0, 0, 1. Yeah, and that's it. Okay. And over here you have 1, 1, 0. Then anyway, 0 is there only. Okay. So this is again binary in sets of 3. So you have 1, 0, 1 is going to be what? It's going to be 5. 1, 0, 1 is 5. 1, 1, 1 is 7. Then 1, 0, 0 is 4. 0, 1, 0 is 2. And 1, 1, 0 is going to be 6. Okay. So this is your octal number. Have we written it correct? So let me check 0, 1, 0, 1, and then 1, 0, 1, 1, then 1, 1, 1, 0, then 0, 0, 1, 0. Yeah. Yeah. So we are fine. Okay. Okay. So any doubts on number systems? Okay. So there is apparently one more problem on number systems. Okay. So this is a simple question. So the question is find ones and twos complement. Of 1, 0, 1, 1, 0, 1, 0, 0, 1, 0. So find the ones and twos complement. So how will you find ones and twos complement? So ones complement, just you have to negate the numbers, right? So it would be 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, right? So this is ones complement. Just replace ones and zeros. And what is twos complement? Twos complement is basically ones complement plus 1, right? So 0, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1 plus 1, which means that over here 1 plus 1 is going to be what? What will be 1 plus 1 in binary addition? 1 plus 1 is going to be 2, which is 1, 0, right? So 1 plus 1 is 0, carry forward 1, so 1 over here, and rest of it is going to be same. Okay. So this is your 2's complement. So any doubts so far in number systems, or is it fine?
Fine, sir.
Okay, great. Just give me 4-5 minutes and we can start off with Boolean algebra. Okay.
Okay, sir.
So yeah, we'll start with Boolean algebra. Just give me some 4-5 minutes. Okay, so let's go ahead now. So the next questions will be mostly based on Boolean algebra. Yeah.
So the question is the expression of the following switching circuit in binary logic notation is dash. So they have given a switching circuit. We have to write it in binary logic. So the circuit is something like this. So you have a voltage source over here, right? You have two switches in series. Okay, let's call this switch A and this is B. And you have the output C, and there is a bulb that is connected across it. Okay, so there is a bulb over here. So what is a switching logic notation, right? So there are some options over here, that is A into B into C bar, A into C into B bar, A plus B into C, and D, A into B into C. Okay. How do we solve this question?
Sir, can this question be solved visually, or is there any method to solve? Because visually I can see that A and B are in series, so they must be in AND position, and C is in parallel. That's why we need the complement. So A option. So is this the visual inspection, or any other method is there, sir?
Yeah, so you told the option correctly. So it should not be in add position. It is multiplication position, right? So it should be AND operation.
Yes, sir. Yes,
Yeah,
sir.
you
Yes.
told. Yes, you are right. You are right. That's how you do it visually only. Or if you want to do it like mathematically also, it's possible. But the point is, let's consider this is the node X, right? This is the output you want. Okay. Yeah. So you have to write the truth table. Visually, you can directly write, that's the best way. But what you can do is you can also write a truth table in the sense that you have A, B, C, right? And you will have X. X is your output, right? That's across the bulb. Okay. So you have all possible combinations. So if it's 0, 0, 0, then you have X is 0, on 0, 0, 1. Then you have X as 0 and so on all the way till 1, 1, 1. Okay. Again, your X will be 0 in that case. So the only option where you would get a 1 in the output is if you have 1, 1 and 0. Okay, you will get 1. So then what you do is all others are going to be 0. Okay, so then what you do is you draw the K map again. So you have C over here, and you have C over here, and you have AB over here. So in C you have 0 and 1, in AB you have 0, 0, 0, 1, 1, 0, 1, 1, and you know that when AB, both A and B need to be 1, only then you are getting a 1 over here, right? So your 1 will happen at C is 0 and AB are 1, which means over here all other entries are 0, right? Correct? So what is this? Basically, this is A into B into C bar. This is the only mathematical way of doing it. That is writing the truth table and the K map. Fine. You can follow this for probably complex circuits if you cannot tell it visually directly. Okay. Is this fine? Let me take it from there. Okay. So we will move ahead with next question. So again, 7 is a very standard question. Something that many of us have solved it many times. So of the functions P1 and P2, to a my computer is hanging. The minimum number of literals are. So they have given a truth table. We just need to find out the expressions for P1 and P2. So minimum number of literals are dash. Okay. So the truth table is A, B, C, P1, P2. Okay, and you have all standard entries. I don't know why my computer is actually hanging a lot. Okay, so I have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and then 1, 1, 1. Okay, and P1 is 1, 1, 0, 1, 1, 0, 0, 0, right? And P2 is 0, 0, 1, 1, 0, 0, 1, 1. So what is P1 and P2 is a question. So visually seeing itself, I think you can tell what is P2. What is P2? What is P2? Can you see visually and tell from the table itself directly what is P2?
Sir, it is B.
Yes. So P2 is B, right? Okay. P2 is B. Well and good. So we will not draw the K-map for that. We will just draw K-map for P1. Okay. Okay. So for P1, let's draw the K-map. So you have C and this is AB 0 0 0 1 1 0 1 1 and 0 and 1. Okay. So the entries are when all three are 0, you have 1 and then and then 0 0 1, right? You have 1 and then 0 1 0 1 0 0 0 1 1 is 1 and then 1 0 0 is 1 and then everything is 0. Okay, fine. So the question is that sorry, so here we did a mistake in the K-map, so obviously it has to be swapped. So it should be 1 1 and then 1 0. Okay. So 1 1 0 is 0 and 1 0 0 is 1 and this is 0. So what should be the combination for minimum number of literals? So for minimum number of literals, what we can do is we can club these two together, okay, and we can club this and this, okay. So we'll be having two expressions, or yes, two sum of products, okay. So we'll be having two sum of products, which over here translates to A bar C plus B bar C bar. Is it fine? So this translates to B bar C bar and this translates to A bar C. Okay, is this fine? Okay, so we have to choose the minimum number of literals. Therefore, there is no point choosing this. Okay, no point choosing this because it has already been included. You will be including a redundant term if you group this together. Okay, the only thing is that you have to all elements need to be included. That's it. It's not the same element will be included multiple number of times. That means that you are adding redundant expressions. Okay. Okay. So I think this is fine. We will go ahead with the next question. Okay. Okay. So the question is question number 8. The Boolean expression for output X is dash. So they have given a logic circuit over here. So you have A and what is this gate? What is the gate? This is X. Okay. Okay, so what is this gate? This gate is OR gate, and there is a bubble, which means this is an OR gate. This also is an OR gate, and this is a NAND gate. Okay. So we have A coming over here, B coming over here, which means that after the OR, it's going to be A plus B the whole bar, right? You have C coming over here inverted, so C bar. So which means B plus C bar the whole bar. Okay. So what is your output? Your output is going to be A plus B bar, right, into B plus C bar the whole bar.
Sir, another bar over the
Yeah, correct.
two.
Total bar. Yes. Fine. This is the answer. Okay, you can simplify it, but the point is, in the question, the options that are given in the question, they are not asking you to simplify, just the expression alone is enough. Okay, you can go ahead and simplify applying rules. So A into B, these you must be familiar with. That is, A into B the whole bar is equal to A bar plus B bar, and vice versa. A plus B the whole bar is equal to A bar B bar, right? So you'll be familiar with these expressions. You can go ahead and solve it. Okay. Okay, so we will go ahead with the next question. This is a simple question. The timing diagram of a logic gate with inputs A, B, C and output F is shown. The type of logic gate used is dash. Okay. So the question is, A is given to be okay. This is A, and you have B, which is okay. This is B, and C is okay. Now the output F, right? These are the inputs. The output F that is given is, so let me draw very small lines for Okay. So the output F that is given is so what is the logic gate used over here? Is it AND gate, OR gate? So the options are AND, OR, NOR, NAND. So what is a logic gate? Seeing this. So over here you see that F and A are same. Okay. F and A are same, right? So what is the output you are getting over here? So is it an AND gate, OR gate, NOR gate, NAND gate?
That the output is high whenever all the inputs are high, sir. So it
Yes,
signifies
so
an AND gate.
correct. It's an AND gate, correct. So I think in Boolean algebra itself, like we have seen different types so far, right? So one is based on timing diagram, and one is based on the logic circuit, and in one based on the truth table, and one based on the electrical circuit. Okay, so we have seen 4 different kinds of problems so far. Okay, so we'll go ahead with the next type, right? That is simplification of the so simplification of the Boolean form. Okay, so simplify a b bar plus a into b plus c the whole bar plus b into b plus c the whole bar. Okay, so let's write this a b bar plus a into what is b plus c the whole bar?
B bar dot C bar, sir.
B bar c bar plus b into b
B bar
bar
dot C bar, sir.
b bar dot c bar, correct. I don't know why my computer is hanging a little today. Okay. So AB plus A B bar C bar plus B B bar C bar. So what is B B bar C bar? This would be directly 0, right? Because if B is 1, B bar is 0, and if B is 0, B bar is 1. So anyway, there would be a multiplication by 0, which means it is completely 0. Therefore, what you end up is with AB plus AB bar C bar. So, sorry, AB bar.
Sir, that is AB bar. Yes, yes. AB bar. Right now, it's correct.
AB bar, yes. Which means AB bar into 1 plus C bar. So what is 1 plus C bar? Anything plus 1 is
sir.
always 1. So yes.
1.
So 1, therefore it is just the first term, AB bar alone. Turns out that the rest of the terms are actually redundant. Okay. Okay. Very simple question. So let's go ahead with the next one.
Sir, do we cover the gate conversions like the universal gates, NAND and NOR, so that we can convert any other expression in NAND and NOR, sir? Is it inside the syllabus or is it higher version, sir?
Probably it may not be there in Introduction to Electrical Engineering. Right?
Okay. Thank
Supposed
you,
to be
sir.
an entry level course, right?
Okay.
Okay. So again, they have given us a truth table over here, which means A, B, C, and you have F1, F2. So you have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and then 1, 1, 1. Okay. I have 1, 1. Okay. So this is the truth table that's been given. Okay. But the question is, we have to write it in terms of max terms. Okay. So you know of max terms and min terms, where min terms actually corresponds to sum of products, right? Wherein you group logic 1 together. Okay. Whereas in max terms, it's the opposite. So you'll be grouping product of sums. Okay. So we have to write this question in terms of product of sums. Okay. Okay. So the first question, the question is, the expressions of F1 and F2 in the product of max terms. R dash. So option A, F1 is equal to 50135. F2 is equal to 50357 and F10356 F. Okay, so for product of max terms, what will you see? Will you see the 0 points or the 1 points? So the 0, 1, 2, 3, 4, 5, 6, 7. Okay, so for product of max terms, you will see the position of the zeros or ones. You will see where the zeros are there, right, for max terms. So for min terms, you will look out for logic 1 and you look out for logic 0 in. So for F1, it is logic 0 over here, here, and here, and here, which means position 1, 2, 4, and 6. So F1 is, in terms of max terms, it is 1, 2, 4, and 6. Okay. What about F2? F2 is 0 here, 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 and here, which means 0, 3, 5, and 6. Okay. Okay. Therefore, the option is D. Is this fine? For max terms, you should look out for where is the position of zeros. Okay, what is the position of zeros? Okay. So in continuation with the same question, right? In continuation with the same question, the question is the simplified expressions. The simplified functions f1 and f2 the product of some form or dash. So f1 and f2 needs to be written in the product of some form. Okay. So again, let's go back to our K table, so our K map from the truth table. Okay. So for F1, right? So you have A, B, C, so 0, 1, 0, 0, 0, 1, 1, 0, sorry. 0, 1, 1, 1, 1, 0, okay. So if we have to write the truth table, right? So the 0, 1, and 3, 2, then 4, 5, 6, 7. Okay. So we just wrote that F1 is 0 at 1, 2, 4, 6, right? So 1, 2, then 4, and then 6. Okay. And all other places it is 1. So this is the table for F1. And again, we have to go ahead and group it. We will group it in terms of zeros. Okay. We will group it in terms of zeros, which means that you will be grouping. Obviously, this will be alone. Okay. And this together, and this together. Okay. So what is F1? F1 is going to be for the element which is alone in terms of max terms, right? In terms of product of sum, right? So you'll be writing it as so you will write it as A bar plus So this particular 0 can be written as A plus B plus C bar, right? A plus B plus C bar, right? So this is done. And let's write this particular combination, which means that it is going to be A is changing. So B bar plus C, right? And this particular combination can be written as A is fixed 1, so A bar, and B is changing and C is fixed, A bar plus C. Okay, so is this fine? How we wrote F1 in terms of max terms, is this fine? Hello, is this fine?
Yes, sir. Fine.
Okay. So the same thing if we have to write it in sum of products, right? If we have to write the same thing in sum of products form, then what would be the expression? For that, what you would do is, let's redraw the truth table once again. So
Sir, actually, I am a little bit confused.
yeah,
Sir, when to go with this A and B, C, and when to go with A, B, and C?
it's totally your wish, totally your wish.
Okay, okay, sir.
So you are asking whether the table will be a 2-row and 4-column table, or will
Yes,
it be a 4-row and 2-column table?
yes, yes, exactly, sir.
It's totally your prerogative, totally your wish. You're comfortable with whatever, and it's totally your wish. Just make sure that 0001 and 11 and then 10. Just make sure this is
Yes,
taken
yes,
care of.
yes, yes, sir.
Totally your wish.
So, one request, sir.
Yeah.
Can we just do this in A, B, C so that we can get like A, B
Yeah.
should
So
like a two.
F1. So okay, got it. So F1 is I have done like this. F2 we will do it in A, B, and C. Okay.
Okay, okay, sir. Thank you.
Okay. So for if we have to write it in sum of product form, you will be grouping ones together, right? So this and this together, this and this together, and this is the lone one which is separate. Okay. So F1 then can be written as A bar, B bar, C bar, right? This is for 1, right? A bar, B bar, C bar plus A into B, right? A into B. And then for this, A is changing, B and C are constant. Plus BC. Okay, this is how you will write. You got it right. How we are writing, how we are grouping and writing. This is product of product of sum, and this is sum of product. Okay. So if you have to write in product of sum, it's max term. Group zeros. If you have to write sum of product, it is min term. Group 1. Okay. Is this fine? F1. Sum of product and product of sum form. Are you understanding how to write? And see, for product of sum form, you want to obtain 0. That is why, for example, if you take this particular instance, here it is A is 0. Therefore, you keep A as it is. And B is 0. You keep B as it is. And C is 1. Therefore, you have to do a C bar so that you can obtain 0 over here. Got it, right? So for max terms, you always concentrate on how to get logic 0. For min term, you concentrate on how to get logic 1. Okay. Okay. So let's write for F2 then. So as you requested, we will do it in 0, 0, 0, 1, 1, 1, 1, 0, and 0 and 1, and A, B, and C. Okay. And let's name this. So this is 0, this is 1, then this is 2, this is 3, and this is 6, this is 7, and this is 4, and this is 5. Okay. So now let's go back. What is F2? F2 is pi of 0, 3, 5, 6. So at 0, 3, 5, 6, it is 0, 0, 3, 5, and 6. Okay, and rest are all 1. Okay, so let's group it now. Okay, so let's group it now. And you know, all of these are very alone, right? These are all alone. Therefore, we have to write them separately. There is no other go, which means that F2 is equal to what? Separately, we have to write in terms of product of some form. So, okay, so we are writing in terms of product, sum of products form first, okay? Because we have grouped ones together. Okay, so let's write the sum of products forms first. So one is alone anyway. So A and B are 0. So A bar, B bar C plus this is done. This is done. Then next comes this, that is A bar, B C bar, and then if you come to this, it's going to be A B C, and finally if you come to this, it is going to be A B bar C bar. Is this fine? We have just written separately. Okay, and if you have to write what is the POS form, that is product of some form, you should be looking for zeros. Okay, so let me redraw this A map. So you have okay, so let's group all of these together. So you have to group zeros, right? So 0, 0, this is another 0, and this is another 0. Okay, so now if we have to write it, right? So F2 would be what? So this particular 0 would be A plus B plus C. So all of them are 0, you get 0, which is absolutely fine. And then you get A for particular A plus B bar plus C bar. And for this you get A bar plus B bar plus C. And finally for this you get A bar plus B plus C bar. Is this fine? We have written it in both sum of products and product of some form, and as you told, we have written it in a 4x2 matrix, 4x2 table. Okay, you will get the same answer. Fine. Okay, so I hope this is fine. Let's go ahead. We still have got just 2 more questions. Very simple questions, but yeah. Is this fine? Like, can we go ahead?
Yes, sir.
So we'll move ahead with the 13th question. So they have given you a multiplexer, and this is 0, and this is P, and this is R, Y. Okay. So the question is, the output Y of the multiplexer is dash. Option A, P, R dash, P dash, R dash, P, R, P dash R. So what is the answer? What is phi? So do you know about multiplexers? Like any idea, or should I explain what is multiplexer first?
Sir, we know multiplexer, sir, but
Okay.
I was also confused. This same question was almost similar to that in assignment. The figure was not there in the assignment, sir.
Oh,
So,
okay.
so these are the issues we are facing daily while doing the assignments and the theory exams,
Okay.
sir. So I assume that it is a 2:1 multiplexer and then solve the problem. But here
Correct.
I guess it is option B as it is 0. Or I'm little bit confused here, sir. Can you please explain
No.
this, sir?
For multiplexer, you understand something like this. Okay. So what is a multiplexer? Multiplexer is just like a channel selector, right? That is, you can select either this or you can select either this, right? Agree?
Yes, sir.
And R is like your enable signal. Unless you get R, you will not get any output. Okay. So now let's draw the truth table. So this is anyway 0, I'm neglecting it. So you have P and you have R and you have Y. Okay. So it can be 0, 0, 0, 1, and 1, 1, 1, 0. Okay. So let me rewrite in a different arrangement. I think it would be better. Okay. So R can be either 0 or it can be 1, and accordingly P can be either 0, 1, 0, 1. Okay. Fine. So the idea is that if R is 0, irrespective of whatever input you give over here, Y is always 0. Okay. R is like the enable pin. Only if R is high, the multiplexer will work, or else it will always give 0. Okay. So R is 0 means Y is automatically 0. Got it? And if R is 1, then what would happen is if R is 1 and if R is 1, you will be getting exactly same as P. So if R is 1, Y is equal to P if R is 1. Okay. So idea is that Y is equal to P if R is 1, therefore Y will be 0, 1. Okay. Got it till this point?
Yes, sir.
Yes, sir.
Yes, sir.
So what is the output now? Can you tell from these 4 options? We have drawn the truth table. This is the truth table.
Option C, sir.
Correct. So it is option C. And the next question is, what is the gate? AND gate, OR gate, NOR gate, NAND gate. These are the options. So what is the?
It's a AND gate, sir.
It's an AND gate. Okay. Simple.
Sir, here
Let's
we
draw the
got
truth table.
here we got yes, sir. Here we got the diagram, so we can tell this is AND gate, sir. But there the 4 options are there, but no diagram is there.
Oh my
So-
God, it's
So
okay.
I thought it is the OR gate. So
Okay. So just try to relate with this problem. The point is, I'm no way related to how the questions are being set or how the answers are being set. Okay, so I'm not even aware of those questions. So then if it were in my hand, I could have probably corrected it or something, but I can't do it.
sir, can we give an email to the email ID that we are given, sir?
Email
Regarding
means?
these issues, sir, there's a email address which I am just telling you the address, sir. Just a minute, sir. Hold on.
No, like what would I do? Because like I'm not supposed to be involved in that. So it's better that you only contact them. I'm not supposed
Yes,
to
sir.
be involved in this.
It is written, in case of any issues, please write to nptelexam@nptel.iitm.ac.in. So
You
I guess
write
we
to them
can write.
directly.
Yes, sir. Because of the every week we are facing the same issue, sir. So it is better we
Oh,
should let
okay.
them know.
Correct. Probably some images are not coming or they
Yes, sir.
forgot to upload. We don't know.
Yes, sir. Okay. Thank you, sir. It was really a nice session today, sir.
Okay, okay. Thanks very much for joining. Yeah, this concludes the session. And yeah, so this was week 7, right?
Actually, I feel, sir, I guess this is the easiest week I'm going through, sir.
Yeah, with the digital electronics is actually pretty easy. So I
Yes,
guess
sir.
the toughest one would have been probably two-port networks.
Yes, exactly,
I don't-
sir. You guessed it right, sir.
Yeah. Anyway, actually, we will be holding an extra session also. Apart from the 12 weeks, there will also be a 2-hour session extra that I will conduct. So in that, I was actually planning to cover only two-port networks because all others can be solved if all the circuit problems can be solved with basic circuit theorems. If you know that you can solve them, and likewise, digital electronics or BJTs are also pretty solvable. So I think the two-port network is the one that can be confusing because you are having those G and H parameters, ABCD parameters, and a lot of matrices involved over there. So I thought we can cover problems exclusively based on two-port networks in that session. Okay, but that will be
Yes, sir,
after the
definitely.
12 weeks.
Yes, sir, definitely, sir.
Okay then. Good night, everyone, and I will just stop sharing. Yeah, thanks for joining, and have a great week ahead. Bye.
Thank you very much, sir. Thank you.
Thank you, sir. Good night.
Yeah, thank you.